Hello YouTube and welcome back to yet another tutorial. Today we're going to be expanding on what we made the last time. Last time we made this little dude who can move around and turn. And that's basically all we did last time. Today we are going to make the movement better. We're going to improve the movement because next time I want to do some collisions with you guys so we can actually have stuff that we can, like walls that we can collide with and all that sort of good stuff. So right now, as you can see, the movement is very like boxy or sharp. And another problem that is also occurring is if you're moving diagonally, you'll actually move faster than moving up or left or right. So we want to fix that. We want to move equal speeds all the way around. So let's get into it. I have the project opened here, and first of all, let's go to the create event. And then in the movement part here, we need some more variables. First of all, we need a friction. This is how much friction is added when you aren't like if you have a speed of 3, and if you release a key, this will be the amount that you slow down each frame of the game. So let's just put that at 0.5 or something. Then our acceleration, let's put that to Now let's actually put that to 0.1. No, just put it to 1 actually. We want a faster acceleration, so let's just put that to 1. And now what we need the our velocity. So we need to calculate, because we aren't going from 0 to 3 when we move, because that's what we're doing right now. We're instantly going up to the speed of 3. But what we want right now is to gradually go up there. So we want a velocity variable that accounts for our current speed. And then we want to use our speed variable to make sure that the velocity doesn't go over that amount. So we're gonna write velocity like this, and we're gonna equal it, and we're gonna do something different here. We're gonna make this an array. So we're gonna do 2 square brackets like this, an open and a closed one, and then we're gonna do 0, 0 inside of here. So basically what this does, first of all, let's go over actually what an array is. So we had a variable last time that can store one value like this. Like acceleration is equal to 1 now, friction is equal to 0.5, and the speed is equal to 3. An array is basically a variable that can hold more values than just one. So you can have an array, let's just do array. And then usually how you define an array is you do square brackets afterwards. And then you put in whatever number of the array that you want to assign this to. So right now, array at position 0 will be 1. You can do position from position 0 to pretty much endless, I think. I don't think there's a cap on it. So right now, array 0 at our variable array position 0, the value will be 1. We can also do one that's array 1, and you set that to 3. So now this variable called array has 2 different values in it, 1 in the 0 position and 3 in the 1 position. So that's basically what an array does. So up here in the velocity, the way this is also an array, and it's not quite written out as the one that I just showed you. It's written out using a different method. So if you are initializing an array, you can use the you can just write whatever name you want for the array, like a variable name. So this one's velocity, and then you can set it equal to square brackets, and then inside of here, this will be the 0 position, this will be the 1 position, then you can put a comma again, and you can assign something to the 3rd position in the array, and so forth and so on. So every time you add a comma, you can add another position. But right now we want a value for our x value and our y value, so that's 2 positions. So this right here would basically be the same as writing like this. So velocity at position 0 equals 0, and velocity at position 1 equals 0. So this way and these 2 ways are exactly the same writing. So this right here makes the same as this. This is the first position, or the 0th position. This is position number 1, just like this. So it's just easier to write it like this. That is pretty much all. We are going to do one more thing, and that is actually we're going to create a new object, because we want a controller object that controls different stuff that we want to use later on. So right now I'm going to go to create a new object and just call it oController. I just used CONT for short for controller. And in here I'm going to use this for a lot of different stuff like scores and macros and stuff like that. So right now what we want to do is actually create a macro, so using this X and Y position, this will be easier. And we're not going to give it a sprite or anything, because it's just going to be invisible inside of every room. So we want to make it persistent. Tick off visible. You don't have to. If there's no sprite, you won't see it anyways. But let's just leave it on actually, so you can see it. So what we want to do in here, we want to define 2 macros, and the way you do that, you use the hashtag or the number symbol or whatever, square, whatever you want to call it. And then you type macro after it like this. Then you want to define the macro, so in this case it's going to be X, and then the value that X has, it's going to be 0. So every time we write a capitalized X right now, it's going to be a macro, that's going to be 0. We're going to do the same with Y, a big Y, and we're going to call it 1. So that's all there is to it right here. Just close down that object, and remember to put it inside the room. Just put it inside, like up in the corner or something. And then now every time we want to access our X or Y coordinate velocity, we can use the big X instead. So that's the first part of it. These are all the variables and macros that we need to make the new movement system going. Now we go in here and we delete all this. We don't need any of it. Screw it, we're not going to use it. We're going to do something completely new. So what we are going to do, we're going to have some local variables, and they are going to be called the following. So we're going to have a dx. Actually, let's use dir x like this for direction x, and then we're going to have direction y, and I think we're just going to have like normal dir. And I have, why is this? Okay. We're actually going to change this one to facing. Let's just do facing instead here, because I want to use the direction for something else. And let's just do a variable for that. Variable facing equals that. And then we're going to have a variable dir here. So now that we have initialized all these local variables, then we can use them. And there's 3 kind of variables, I should say right now. Or actually 4 if you count the macros in. But we have the local. It's these ones where you write var in front of for variable. And they are local to this event only. So they can only be accessed through the step event. So if I would try and access the value that direction x had in the create event or in a draw event or any other event, you couldn't get it, because it's only for this step event right here. And the benefit of these is that they have a very, very fast lookup time, so it doesn't take your processes that long to find the values as it does with normal variables. And then we also have global variables, which can be global dot and then whatever the name, so variable like this, global to variable, and that means it can be accessed from anywhere, from any object can access it, any piece of code, whereas normal variables can only be accessed inside the object that you're currently working on. So right and left and up and down will only be accessible inside this object and not in the controller. But if we made a global variable, we can access them in both objects. And the same goes for macros. These guys here, they are global too, so you can access them from anywhere within the code. Now we need to do something. We need to have direction x right here. We need to set that equal to 0, and the same with direction y. And this is important. I'm going to explain it a little bit later. So these, or actually let's just explain it now. This direction x and y will be a reference to our position, our origin, is going to be the point at which we calculate what direction we're going in from. So it's going to be our 0, 0 point, and then we're going to calculate the direction based on that. So now we're going to use an if statement. We're going to do a bit more advanced one right here. We're going to write right, and then we're going to do 2 of these lines here. This is an or sign. You can write or instead, like that, but I prefer to do like this. So if right or left, this will check if either one of these is true, then it's going to run this code that's in here. So if we're pressing right or we're pressing left, then what we're going to do is we are going to make a like add a direction from the 0 point to either left or right. So what we'll do is we'll say direction x will then equals right minus left. And the reason why we're doing this is if we're pressing right, then that will have a value of 1 because it's true. So true is a value of 1. So if we're pressing right, then we'll get 1 minus left, and left will be 0 if we aren't pressing it. So it'll be 1 minus 0, so that'll be 1. If we're pressing left and not right, left will be 1 and right will be 0. So then we'll have 0 minus 1, which will be minus 1, which will make the player go to the left. So we're going to do the same for up and down, like this. So if we're going up and down, it's important that you separate them into vertical and horizontal, because if you put them all in the same, then it won't work the same as good. So it'll mess up your code. So you have to do it like this, and then we're going to have direction y will then equal down minus up this time, because if we want to go up, we want to subtract. So it has to be the opposite way of right and left. So down minus up, like this. So right now, then we want to have a now we want to calculate the direction that we're going in, and that's going to be used the dir, and that'll be point direction, like that. So we'll point towards a direction. So we're going to point from, let's just minimize this, we're going to point from 0, 0 to our new direction x value, which can either be 0, which will be set to here right every time, or it could be 1 or minus 1, and our direction y value. Now we want to make our player go in these directions. So under this, we're just going to make a comment, move the player. So we're just going to comment this out. Reset the direction. I'm going to explain every bit of this after this. When I'm done coding it, I'm going to go through it line by line and explain it. So check for key. No, we're not checking for key presses. We're gonna actually we're gonna we are not gonna comment this out because I don't want to know what to write. But right here we're gonna calculate the direction that the player needs to move, like that. So we're going to calculate the direction that the player needs to move, and then we're going to move the player. So this is where the variables that we created before comes in, because now we want to add acceleration to our velocity. So what we're going to do is we're going to have velocity like this, and then we want to access it by putting in square brackets like this. And the way you access an array, you can either just do it like this and just write 0, so you're going to access the whatever value that's in the 0th position. But a safe way to do it, that you should use, if you ask me, is to add an @ symbol, the male symbol, whatever you call it, the @ symbol I think it is, and then what you want to access. So this time we want to access the x location, which is basically the same as writing 0. But these are different for different types of data structures, for different types of data structures. But we'll talk more about that later. But for now, just remember, if you want to access an array, a value in an array, you want to use the accessor. Because if you're using scripts and you're not doing this, it'll fuck up your code. It'll mess up your code. That's what I wanted to say. No swearing here. Okay. But it'll mess up your code if you're using scripts sometimes and you're not using the accessors. So it's just a good idea just to use them because it's safer and it's more reliable. So, what we're going to do is, our velocity x at the x position will be plus equals. We're going to add the friction to it. So what we want to do is, we want to use a function called length x, which will actually take it'll calculate depending on a vector. This right here that we actually made a vector going from 0, 0 to whatever direction we're going in. It'll take that vector and it'll just take the x length, the length of it in the x direction, and then add it or whatever you want to do with it. So right now we're going to add the length of the vector in the x direction to our velocity's x component. So the length right here that we want to move in, that's going to be acceleration. We're going to plus equal that to our velocity all the time while we're moving, and in the direction of like this. And because we want to only do this if we're moving right or left, so again we're going to do an if statement, if right or left. Then we're going to use this here. Then what we want to do is actually want to do an else statement after this. So with if statements, you can also make an else statement after an if statement. And what that basically does, it says, if this is not true, if this returns false right here in whatever you have inside of the argument here, then you'll run this code instead. So instead of, if we're not pressing left or right, then we want to actually slow down the player. So we want to use a function here, and it's going to be the lerb function that we want to use. So velocity add x, like that, a big X, remember that, will then equal lerb, because this function, what it does, it takes one value and makes it smaller or bigger. What can you say? It takes value 1 and tries to get it to value 2 by an amount that you put in. So that's how to think about that. So right now we have a value 1, that's going to be our velocity x. That's our current value that we have. And then we want to make it reach 0 by our friction amount. And we actually want to go and change friction, because this is actually in percent. So it's going to take like 60 or 50% each time. So we're going to do 1.1. So right now it'll slow down the player when we're not pressing anything. And we're just going to copy all this. And then we're going to do the same right here. This is going to be move the player. We're just going to do this. And then this is going to be horizontal movement. This is the horizontal movement. And this is the vertical movement. Like that. And then instead of right here, we're going to check if we're pressing up or down. And then instead of velocity x right here, we're going to use velocity at the y positions and just replace the x's with the y's. And then instead of length direction x, we want to get the y component. So now we're almost done. We'll just go through this and we can just test it real quick, because it won't work right now, and I'm going to explain to you why. Because this is something that I had some trouble doing, and why the hell is this not... Oh, we haven't spelled this right. Okay, there we go. And actually, wait a minute, sorry for that. Just delete this variable thing here. We don't want to make that. We want to access that, because that's going to be this one facing. There we go. Save it and play it. Okay. Here we go. Let's test it out. So as you can see, we can still turn around, but we can't move. The reason is, right now, we're only setting the velocity. We're just adding numbers to this velocity variable. but we're doing nothing with these numbers. Before, we added the speed to our x position, and that's what we need to do with the velocity too, and the y position. So what we want to do is, we actually want to add another event. It's going to be the end step event. So go into the step event and add an end step. So the difference is, they behave the same, it's just there's a difference in when they're executed. So the step event will be run through, and then the end step event will be run through. So it'll go after it, and it can sometimes when you do different sorts of calculations, you can get some offsets and some weird stuff happening if you do not use the end step. So right here we want to say x plus equals velocity at the x position, and the y plus equals velocity at the y position. There we go. So right now we're going to do this, and you should see we can move now. But the problem is, we're going way too fast. Like, it's going to go infinitely up all the time. So you can see right now the player's not even here. Yeah, they came back. You saw that? Way too fast. So what we want to do instead is, we want to clamp this value. So we want to make sure that the velocity does not go over our speed, the speed that we set in here. So the speed of 3. Okay? So how we're going to do that? It's pretty simple. We are just going to say velocity, like this, velocity at our x position equals clamp. This is a function that clamps a value. So we're going to have a value that it'll clamp. It's going to be the velocity x value. Then we're going to have the minimum value that this variable can have, and that's going to be our minus speed, and the maximum, which is going to be our speed, the full speed. So this velocity can now go from anywhere from -3 to +3, -3 to +3, and we're going to do exactly the same just with the y component, like this. Okay, so there we go. Let's add this in. We've added, started the game. We can now move in all directions, and we should not move faster when we are moving diagonally, even though it kind of looks like we're moving faster, but I'm pretty sure should not be moving faster at all. This should work, foolproof. Oh, I actually don't think it does. No, this does not work actually. And the reason why, right now... yeah, okay. So we're adding our acceleration to the velocity x. And then... but we're measuring the length of the x component and adding that too, but in here we're still clamping it to 3, so it should actually not be allowed to go a little bit smaller than 3. So how are we going to fix that? I have fixed it before, just can't remember how I did that. So see, this is what I talked about in the previous video. I want to do this with you because I didn't really plan for this, so we're going to learn something together by figuring this out. So how do we do this? We want to make sure that this okay. So instead of using acceleration, let's just try and use speed here, because that'll solve it for now. Should solve it. Okay, let's do this together. So what we're gonna do is actually, what I'm gonna add. So we're gonna do some hunting here. So we're gonna add a draw event, and we're just gonna add normal draw event because in here we can do draw text, and then we can just place that in the 0,0 position. Actually, let's do 10, 10. And then we can add a string in here. So what I want to use is I want to use the string function, which returns a value and makes it into a string because it has to be a string in here. And then it's going to draw that here. So we want to do velocity, add x in here. And then we want to copy all of this, and we just want to move the other one down to like 30. And do velocity y in here. Okay, so this should write on the screen whatever our velocity x and y is, like this. Oh yeah. Okay, I forgot something. We have to draw self also. Draw self like this, because if you add the draw event and add something in here, it won't draw the sprite. So you have to use this draw self function. Learn some more stuff here. So right now, yeah, as you can see, we're still moving with a speed of 3 in each direction, which we should not when we're going, because when we're going diagonally, we should actually be moving with a speed that's less than 3, because that's the whole point of using this system. So if we just set it to equal this instead, this will fix it for now. Should do it. Yeah, as you can see, it's equal to 3, and when we move, see now it's like 2.12. So that's the value that we really want. But we don't have the acceleration in here, and we really want that acceleration. So we're gonna figure it out. I'm gonna figure this out to the next time, and because I can't really think about it right now. Okay, so I couldn't find the fix where we can use the acceleration to accelerate up and still have this fluid motion. So for now we're just going to do it like this. We're going to set it equal to length x and the speed direction, because that'll do its job just fine. So we'll do that, we'll save this. I'll try and figure something out for next time, and until then I really hope you enjoyed this video, and make sure to subscribe and stay tuned for the next one, where we're going to fix this and we're going to do some collision. And when we've done the collision, we're going to do some even more advanced stuff, I think. Yeah. Cool. See you then. Goodbye.